Hello, Year 9. Today, in our next lesson on equations, we're going to try and move towards a more formal written method. The benefit of this is we're not going to need to draw any diagrams. We're not going to have to show any inverse function machines. However, we are still going to try and explain how we move from one step to the next in our equation. So I would make sure you've got two different coloured pens, your normal pen colour that you're used to writing with, and another coloured pen which I'm going to refer to as the communication pen. But before we start, let's just do a quick little activity to get our brains awake. I have a grid of numbers. There is a start square and a finish square. You have to start in the bottom left square and move up, down, left, right, form a pathway to the finish in the top right. You need to add the numbers as you go along. Can you find a way of getting from the start to the finish with a total of 53? You might want to pause the video here because I'm about to go through one of the possible answers. So here is one solution. There are others, but 5 add 7 would be 12, add another 6 is 18, add another 6 is 24, add 9 is 33, add 4, 37, add 5, 42, add 7, 49, and finally add the 4 is 53. Did you find a way of getting there? So the method that we're going to look at today for solving equations involves inverses, but it's often referred to as a balancing method, or a method where you do the same thing to each side of the equation. The benefit of this method, it is efficient, and what I mean by that is a quick way of solving equations. Also, the benefit of solving equations this way is, should we move on to some more difficult equations, we are going to be able to solve them using this method. The idea of inverse function machines or equation diagrams do not work very easily for every single type of equation. What I thought we would do first is just see, though, if we can see a link between how we were solving our equations last time, the written part that we were writing down, and what we are doing today. Because in essence, the written part that we wrote down last lesson is very, very similar to what I will be seeing today. So if you can look at our written part over here where it says 3x plus 7 is 16, we've managed to reduce it to a line that says 3x equals 9. Well, how did we do that? Yes, we used the diagram to help. But in essence, what we have done is we have taken this plus 7 and used an inverse. We have taken away that 7, which means we've taken away 7 from here, which has left us 9. So in essence, we have lost the plus 7 by taking 7 off both sides and getting to 9. And the way that I will write this down with my communication pen is, we have taken away 7 from both sides. Then how did we get from 3x equals 9 to x equals 3? Well, that was the part where we split the 9 into 3 equal pieces. And again, that is an inverse, because 3x means 3 times x. So we've done the opposite of times by 3, which is divide by 3. In essence, what I am writing in purple is very, very similar to what our inverse function machine would have looked like. Let's see how this works with a few examples. And if after the first example you're not quite sure what I've done, don't immediately give up. Watch all the other examples and see if it starts making sense. Sometimes not everybody gets everything from the first time you see something. So, in my example here, I have got 3a plus 2 equals 20. I am trying to get to the answer a equals by itself. Anything extra with this 3a and this plus 2 is something that I need to deal with. So what I'm going to deal with first is this plus 2. I'm going to do the opposite, the inverse of plus 2. I'm going to take away 2 from both sides of my equation. When I take away 2 from both sides of my equation, the takeaway 2 will get rid of the plus 2, and I will just be left with 3a. If I take away 2 from this side of the equation, 20 take away 2 leaves me 18. So I now know that 3a's are worth 18. I need to work out what 1a is worth. If I know 3 are 18, I need to divide by 3. I need to split that into 3. So my second step is dividing both sides by 3. And that will tell me that a equals 18 divided by 3, which is 6. Let's have a look at this next equation. In this equation, I have 3x take away 4 equals 11. I'm going to try and get the x by itself. At the moment, it is 3x take away 4. So I'm going to do the inverse of take away 4, which is add 4. The reason that I can do that is because take away 4 and add 4 are 0. So that will just leave me with 3x. So by adding 4, it kind of cancels out the take away 4. What do I have on this side of the equation when I add 4? It becomes 15. If 3x is 15, I need to work out what 1x is worth. And I can do that by splitting it equally into 3 parts. And 15 split equally into 3 is 5. Now you might recall it is possible to check your answers with equations by substituting the number back in. So if I took my 5 back up to where x is, well 3x means 3 times 5, 15, take away 4, 15 take away 4 is 11, and I end up with something that makes sense. Let's look at this next one. 2y plus 8 equals 22. Do you think you know what that first inverse operation is? Well, if I've got 2y plus 8, I need to get rid of the plus 8 by subtracting 8. So my first step is to subtract 8 from both sides. Remember, if I subtract 8, it will get rid of the plus 8, and I will just be left with 2y. If I subtract 8 from 22, that is 14. If I have 2 y's, I'm going to need to split this into 2. So I'm dividing by 2. So y equals 7. Fourth example. 5b take away 9 is 16. So 5b take away 9. I need to do the opposite of take away 9, which is add 9. When I add 9 to both sides, that kind of gets rid of the take away 9. So I am left with 5b equals 25. Now the reason it isn't 14b, as some of you might be thinking, is because I'm not adding any extra b's, so it's still 5b. Final step, if I've got 5 b's and I want to work out one of them, I need to split it equally into 5. And 25 divided by 5 is 5. So the answer to that equation is b equals 5. Now, I do have 4 more examples to go through, but this is where you might want to think for yourself. If you think, I think I know what I'm doing, sir, you could try these next 4 equations yourself. If you're not feeling confident, then you can listen through to me going through the answers to these. So I will leave that choice up to you. But I might go through these 4 a little bit quicker. So I have 6b take away 8. I'm doing the inverse of take away 8, which is add 8. So 6b equals 18. I need to now split that equally into 6. And 18 divided by 6 makes b equal 3. Next one, I have 3w plus 4 equals 25. I'm going to do the inverse of plus 4, which is take away 4. When I subtract 4 from both sides, I end up with 3w equals 21. I need to split that equally into 3 because I have 3w. And 21 split into 3 is 7. So w equals 7. This one, I've written it a little bit differently, but 3 plus 4x is still the same as 4x plus 3. So if I want to get the 4x by itself, I need to get rid of this 3. I need to subtract 3. So I'm subtracting 3 from both sides. I end up with 4x equals 48. I need to split 48 into 4 piles, dividing by 4. And 4 goes into 48 12 times. So x is 12. Final example. I've got 2c plus 3. So my first inverse is to take away 3. Subtracting 3 from both sides makes 2c equal 7. And I need to split that equally into 2. What's going to happen here? What is 7 divided by 2? Well, 6 divided by 2 is 3. 8 divided by 2 is 4. 7 divided by 2 is 3.5 or 3.5. And this is probably the first time we've seen in this topic so far an equation not being a whole number. Sadly, it doesn't always have to be. So there are some questions for you to try, so I suggest you go back to my instruction sheet, you have a look at these questions, and remember how I would like these set out. In the last 5 minutes, check your answers using the answers that I've provided. I've shown in my working out all the steps. And remember, if you have any problems, you can ask in the Ask the Teacher channel.